Hello everyone. Before starting, I would just kick off the first slide with a quick introduction. So, my name is Jadan Mindra. I'm a computer science undergrad and I'm a pretty big AI enthusiast. I was introduced to development, basically the Java and Android development, just after my class 12th. I also like a competitive coding. I'm a competitive coder. I just do competitive coding whenever I get time. I was also problem setter for contests on Hacker Earth and CodeChef. That's it. Now we should begin with the neural networks. So let's just get started. Giving an overview of a neural network, and then I will be talking about the types of a neural network. So let's just dig in. So first of all, I want to discuss why neural networks. So why do we study neural networks? Why they are gaining importance these years? So neural networks are not new. They are about 40 to 50 years old, but it has gained importance in like around 2010 or like 12. This is because of mainly two reasons: the large data and the computing power. As these are two images, I just got these two images from Google. This image shows the amount of data that we generate in today's world, and this is an image of a supercomputer with lots of GPUs and CPUs. Oh gosh, I want one. Okay, so this is the data that we generate. So for example, here it is written that 24 petabytes of data is generated by Google every day. Like, it is processed by Google every day. So that's a huge amount. And because of this huge amount of data and the good computing power, it has been observed that neural network outperforms every other machine learning algorithm in almost everything that we apply machine learning on. So it has it has been proved that when we have these two things, like a large amount of data and a good computing power, neural networks outperforms every other machine learning algorithm. So this is a basic neural network structure. It consists of input layer, the hidden layers, and the output layer. So what exactly is an input layer? So input layer is basically the features that input layer consists of cells that have features that we're gonna feed in, and these connections basically have weights associated with them. So our main task in a neural network is to learn these weights. So at a start, we like assign these weights randomly, and then we add a bias to it, and then we just pass it through an activation function. So we see a word written here, activation function. So we just pass it through an activation function, and we just go on and on. So there can be like more hidden layers, and we just do the same thing again and again. So activation function can be like a sigmoid function or a ReLU function. It has been observed that a ReLU function gives more accurate results. ReLU function is a function which given a value, the function returns 0 if the value is negative, and it returns that value if it is a positive number. So that's a ReLU function. So I talked about the weights out here, and that I told you that weights are the thing that we need to learn, and I also told you that we assign the weights randomly here, and we just add a bias to it and pass it to the activation function. So an obvious question is that how do we learn these weights? So what actually happens is we have these randomly aligned randomly given weights at first. Then we move on and do go to the output layer, and finally do the prediction. Now what we do is we compare the predicted value to the actual value, and we find the error. So what happens is that with this error we back propagate, and now we modify our weights. So the modification is done in a way to minimize the error, and hence our output would be like closer to the actual output. This is how we learn those weights. So we just go forward, compare the results with the actual result, calculate the error, do the back propagation, and modify the weights in a manner to minimize our error. So this is how it is done, and here I have written a line that order of events does not matter. What does that mean? This means that the two lines, John won against Joe and Joe won against John, has similar meaning for this neural network. Like, what I want to convey is that this neural network cannot make out itself that what should come first and what should come second. It cannot, like it does not know that John won against Joe means that John won. It can just replace John with Joe also. So this kind of thing, this is a problem with this neural network because it cannot remember the past. It cannot have a memory. Like, we'll just learn further that how neural network have a memory, but this neural network for sure does not have memory. It just have the arrows pointing to forward direction and forward direction, and hence it's basically a feed forward neural network. So let's see what this memory means. So this is RNN, which is a modification to a normal neural network. So RNN stands for recurrent neural network. We see a recurrent relation here. So what we do is, this is a cell and this is a cell. We not only put the output to the other cell, but we also take out a recurrent relation to the cell itself. So what happens is, this output goes to itself only. So this is like in a written in an unfold manner. So we just unfold it and see that at a state t minus 1, t and t plus 1, we can see that this is going to itself only at the stage t. The t stage is going to itself at the stage t plus 1. So this is just an unfold of what is happening here. So it's just pretty easy, normal to the neural network. The only thing here to be noticed is this recurrent relation, which gives it the memory power. But there is also a problem associated with it, that is vanishing gradient problem. Now I told you that we learn the weights by minimizing the error. So we just move forward, compare our predicted value to the result actual value, calculate the error, back propagate and correct the weights. So how do we we just when we backpropagate, we basically minimize the error, and to minimize the error we use a gradient function. So that gradient function, that function gets vanished while going backwards after a few layers. So the weights that are learned are not, like, we can just learn even better weights, like we can just improve that. So let's see how can we improve those things by doing some more modification in RNN. So here comes LSTM, which is like much more efficient than RNN. So what it has is, we can see the input, the output, and this is a recurrent relation as also present in an RNN. Now, yeah, I know that you might be thinking, what the hell is this? Input gate, forget gate, and output gate. So I'll just tell you that we get this output. This is the normal recurrent relation as we had earlier, and this is the output. So what this gate actually represents is that there are weights associated with it. So earlier we just learn this weight, the weight we are passing, and that's it. Now what we have in an NSTM is, we can even have the weight to the input, to the output, to the here only. So each gate is associated with an weight that we have to learn. So it provides us so much power in the sense that we have to learn the weights, so we can just control what we need to remember and what we need to forget. So for instance, this network can even do things like, if I say a phrase that let's say John lives in Germany, so then we have 30 words approximately after it, and then at the end when I say the mother tongue of John is, so it would automatically predict that it's Germany because he was living in German. So that's the power of an LSTM. So this like LSTM has that capability, and it has been seen that it normally does this. So the basic use of LSTM is in text only. We can do a lot of predictions in text by using LSTM. We can say that let's say we have a sentence, so we can just ask it to complete a sentence. So we can actually do that by using LSTM. Just like LSTM is especially used for text, similarly there is a CNN which is specially used for images. It stands for Convolutional Neural Network. This is widely used for image recognition, for images. Anything to be worked upon image goes here. So what happens is, we have an image. Okay, so first of all we need to understand that each colored image has three things associated with it. That is the RGB value: redness, blueness, and greenness in an image. So the value we assign an integer to that value, and the integer ranges from 0 to 255. So we need to understand that this image is actually representing the integers with the values from 0 to 255. So what we do is, in a convolutional neural network we have two things: a convolutional thing and the pooling thing. These two things together form a single layer in the CNN neural network. So what we have is, we form a window out here, and that window, it basically tries to identify a feature in the image. So a feature as in a curve, a line, or something. So it just finds a feature and move forwards. Then we apply a window out here, which is the pooling. The pooling maximize, like, it takes out, extracts the important part from a particular window. For example, this is a window, and the pooling that we do is basically the max pooling mostly. So in max pooling, what we do is, we extract the maximum value in the window and move forward. So yeah, and the convolutional and pooling together form a single layer. So this is how we go on and on. And at the end we have a fully connected layer, which is like a normal layer in the normal neural network. It's just a normal layer, and we connect it to the output, and we finally get a prediction. So that is how CNN works. Okay, so it is like widely used for by Google and Facebook and other tech companies. Google even use it for image searching. The image searching feature of Google is based upon CNN only. The Okay, so now I was just talking about how these like weights are multiplied by the input. We add the bias and pass it to the activation function. So here I have given you the overview of how things work. Now going into the mathematical details, it's like pretty simple. We just have a matrix for the input, we just have the matrix for the weights, we multiply them, add bias, and pass it through the activation function, which may be ReLU function, sigmoid function, or any other. The ReLU function works like better, it's performed better, it has better results. So that's all about the neural networks. We just do some modifications and get the LSTM and the RNN and the CNN. So that was the overview of neural network. Thank you.